Morning, everyone, from beautiful Stanford in central Kentucky. My name is Erid Wooldridge, and I am a professor of additive manufacturing and the director of the AMCOE at Somerset Community College. My background is in engineering, architectural, and manufacturing systems. And I'm going to talk to you today. I've got the big title on the screen of this whole streamlined LCA comparison. What it all boils down to is that I'm going to be talking to you about the environmental impacts potentially between using 3D printing technology versus conventional technology such as injection molding. And specifically in terms of 3D printing, the low-cost additive manufacturing equipment, much like you all are having with this workshop, the model prices, those kind of things. So just to go ahead and get started, to give you a quick background, what is an LCA? What is this topic and what's it mean? And also just, why are we looking at it from additive? So to answer those questions, an LCA stands for a life cycle assessment. And it's an environmental study that many companies do where they look at a product that they produce and they ask the question, what all goes on with this product? For example, let's say you take a fidget spinner. We all love those, right? So they're made of plastic, they're made of steel, we got ball bearings. And an LCA study of a fidget spinner would look at how much energy and environmental impact occurs when we take the steel out of the ground and process it to turn it into a ball bearing, the plastics. What happens to the fidget spinner after you finally get tired of it or you break it? Does it go into recycling? Does that material just sit in a waste dump from that point in time on? So all of those factors get included in an environmental study, and we use that information to make a comparison. So for example, we might compare a fidget spinner to another product in terms of environmental impact. And so an LCA study is very in-depth, very scientific, and it's really after the truth as much as it can about what matters in terms of environmental impact on a product. A very famous LCA study related to additive manufacturing was the GE fuel nozzle back in 2013, 2014. And this particular study looked at this fuel nozzle that GE makes for its turbine engines, and they asked the question, this type of nozzle could be done conventionally, or perhaps we should do it additively, and what would be the difference? The results of that actual study created a great leap for GE, so to speak, in the fact that they realized that the additive was potentially much more environmentally beneficial. So that set the stage for a lot of the work that we do now. Why do manufacturers care about the environmental impact? Why are they interested in doing LCAs? Well, for one thing, many companies are actually environmentally responsible. Sustainability is a big thing for them. Having a planet and resources for our children, our grandchildren, our great-grandchildren matters. Some companies will do it for a marketing awareness, just to make sure that the world knows what they do and that they are conscientious about it. And then another factor that plays in is that government and military contracts are sometimes connected to your environmental impacts associated with your products. So they'll actually get bidding points, so to speak, if they're doing environmental benefits in their production. It gives them more opportunities for long-term contracts. So that's a little bit about what an LCA is. That's about what kind of these studies go with. And the next question is, why do we focus on low-cost additive? So part of what we do at the AMCOE in Kentucky is we look at how do we get more 3D printing going on in schools and companies. And the benefits for additive are pretty straightforward. There are environmental benefits that we will see. And there's also the overall benefits of you can make parts that are lighter, that are stronger, use less material, use less hazardous materials in the process of manufacturing. A very interesting study that was recently done was done by General Motors, and you see that on the screen. That is the seatbelt bracket study, where this particular component that they had been making for years is actually made out of 8 separate parts and is condensed down potentially into one part by 3D printing it. It's lighter, it's stronger, and that set the stage for GM to really start thinking about some transition opportunities. The negative side about all this is that what we're finding is that so many companies out there are not aware of additive manufacturing, are not using it, and are kind of ignoring it. And that's a potential threat. So they have little experience in additive, and they have little awareness specifically in what all is going on around them. You know, many companies work for bigger companies. A lot of companies work for Ford. They work for GM. They work for companies that want to assemble the products they make. And they're just not aware of what's happening. You know, just this month, we already saw a new announcement by GKN, a major automotive component and engine manufacturer. They have a grand opening of a new facility in North America for specifically additive manufacturing powders. Another new announcement is the fact that Centavia just finished up their, is opening up their 55,000 square foot facility down in Florida for additive manufacturing technology. HP just hit their 10 millionth part that was 3D printed. And then when you go even deeper, Stanley Black & Decker, in terms of their Stanley Ventures group, had about 7 of their 22 investments are around additive manufacturing. So there's all these big plays that are happening that most folks don't even realize. And we understand that, you know, to be fair, companies are busy making money. And that's their focus. Also, you don't typically get into industrial 3D printing on the cheap. You know, these machines can cost $500,000, $750,000 to $1 million easily. And so it's expensive. And probably the biggest challenge for the additive transition is that many folks just don't understand how it works. Yesterday, I believe you all had Ed in there talking with you in terms of generative design. And that's a difficult topic for me. You know, going from a part that looks like this, what they've made for years, to something like this is not easy. You know, if you're in Project Lead the Way, then you all have probably dealt with Fusion or Inventor. And you know that if you ask your students to design something like this, that's going to be a real challenge for them. So additive is very beneficial, but it also requires a lot more forethought in terms of design. So in going forward with this experience of the workshop, you know, how are you all going to go back and not only talk to your students, but also just talk to some parents and the business folks and the industries around you and helping them essentially integrate additive? And that's where we start today. You know, what we've started with is what we call the LCAM model, the low-cost additive manufacturing integration. And what it essentially means is that we focus on using low-cost equipment, similar to what you all are doing in the workshop, to establish a beachhead within a company for additive and get them going in the direction that's going to be beneficial for them down the road. And so we start them off with using small equipment, you know, a Taz, Luzbot, I think y'all are using the Monoprice, Ultimakers. They typically cost less than $5,000 is what we deem an LCAM, you know, a model equivalent. And we show the companies, hey, you know, instead of buying these parts, maybe you should start manufacturing them yourselves. And they start to do that. They start to replace parts that they normally buy. And it could be very, very simple brackets or this or that. They start saving a little money, a few $100s there. Before they know it, they saved $1,000. Then we show them how to kind of go bigger. This particular company saved, in a year and a half, saved over $200,000 by integrating a low-cost additive equipment into their industrial maintenance department to just keep things going. Then, of course, your next step after you kind of do stuff like that is to start to talk about it, share with it, tell the students about it, tell the parents about it. And we talk a lot. We go around not only the state, but the nation and speak on this topic as much as we can, because additive is the key for next generation products. So we also tell them about this new concept of what a small business can do with LCAM. You know, a new potential production model for manufacturing. And many of you may already be familiar with this particular company. I'll give you its background story. It's Prusa Research over in the Czech Republic. And they use a print farm, 400 to 500 low-cost 3D printers sitting there making parts for their 3D printers. They make in about 15 hours, they make about 20, 25 parts for their printer kits that they sell. And they sell a ton of these things. We're talking thousands a month, hundreds of thousands of parts a month, all made by its 3D printing brothers and sisters. This particular facility in their report is only managed by 15 people and runs 24/7, just knocking off parts. And so it's an amazing new concept. And in an interview, they asked the owner, they said, you know, why are you doing it this way? You're producing this kind of huge number of parts. Why aren't you using conventional approaches like plastic injection molding? Because it's just such a large volume. And he said the answer is pretty simple. You know, there's several reasons. One, He said, additive allows me to produce parts that are more complex than injection molding can make. So he makes more complex and difficult parts. He said, additive also gives me a simpler workflow. So if they have a part design change, they don't have to go back to a supply chain and wait 6 months for retooling and to make all that happen. They can implement that day if they want to. So the workflow is simpler, and what it also does is what we refer to as the constant beta. Since he can immediately update his product, it allows him to have a new innovation and immediately implement that innovation, which creates a great opportunity for the consumer and the customer to constantly see their product improve. In fact, he actually makes his design files available. So if you have for example, a Mark II printer, you can actually update it to a Mark 2.5 because you can print the upgrade parts yourself. This is a whole new concept. Manufacturers have never had the ability to pivot and respond to market changes fast enough. Going back to the fidget spinner, one of the first things that we saw happen when the fidget spinner started becoming a thing is that we saw people firing up their 3D printers and starting to manufacture fidget spinners and customize fidget spinners to respond to the market desire at the time. A pretty powerful thing. But now we kind of get to the heart and the core of what we're here to talk about today. So that's the LCAM model, but what's it do environmentally? You know, what are we talking about in terms of environmental impacts between this new technology and conventional applications? So we started looking at the sustainability, the lead time, and the economics of this LCAM model versus conventional. And so the study that we did was very, very basic. I had a friend, and she had just bought out a gym company, and she was in the process of rebranding. And I went to her and I said, you know what, let's do a case study with you. So we designed these funnels that you see in the middle of the screen there that are, you know, about this big in size. And they're designed with her new logo on it. And also they are funnels to be used in supplements. So a lot of people go into the gym, they'll pour protein powders and stuff directly into their bottles. So this was a quick little marketing thing that we created for her. And the question was, which way should we go? Now in our case study, we went with 3D printing, but we wanted to compare it to if she had gone and gotten injection molding. So if you're not fully familiar with how injection molding works, we've got a little graphic for you here. And injection molding is fairly simple and straightforward. You take two essentially blocks of steel, rectangular, square, whatever the case may be, and you carve out in each block half of your desired shape. You clamp those two blocks together and you start filling it full of plastic pellets, but you actually heat the pellets up until they become a liquid, and you essentially inject it into the cavity of the mold. You let it cool for a few seconds, you separate the mold, and the part drops out. It's been around for decades. We've been doing it for a long, long time, and all of, like, for example, your automotive parts, your plastic parts, all of that's injection molded. It's great for high volume, it's fast. The limitation factor is it requires a lot of tooling time at the very beginning. So in our LCA study, we went through the normal approach. I won't bore you with some of the details, but it boils down to this. We took each system, the injection molding and the additive and manufacturing approach for making this funnel, and we looked at it from cradle to grave, or cradle to consumer use, and then what happens at the end. Specifically, the tooling that goes into the making of the molds, the injection itself, and you know, what happens to the steel at the end. And with the additive, you know, it's kind of system boundary, the machine, the actual material, any transportation that may be involved with it. We studied all of that. And of course, we make assumptions with some of these type of studies, you know, how much plastic may be lost in the process and used, who's doing the tooling of the mold, how much travel time and travel distance we're talking about, what kind of shipping would be used. We're talking about shipping stuff on a carrier boat or a truck. And then we wanted to look at how many units. Are we talking 500 units? Are we talking 5,000, 10,000, that kind of thing? So all that factors into the overall study, and there's some data there for you to see. But what it boils down to is we collect the data. We have primary data, which we collect ourselves, the actual 3D printing of the funnels, and the secondary data that we collect, you know, based on estimation. We use a software called SEMA Pro. It's highly recognized in the LCA fields. and it's as close as we can get to good estimates. And you know, an LCA or environmental study is not an exact science. You have to make a lot of assumptions, but you do your best in the process to actually make sure it's as reasonable and viable as you can make it. So in terms of our own collection, you can see right there, we're printing off on one of our Prusa i3s, Mark IIIs. We do about 14 funnels a batch, and we used a little device called a kilowatt, and it actually measures the amount of electricity going into the 3D printer during the entire production process. So we print off a ton of funnels, and she uses them for marketing. We enter that data into SEMA Pro, enter the data in on the injection molding into SEMA Pro, and we start looking at the environmental results. And the results were very surprising. You know, a term that everyone uses a lot is called a carbon footprint, and here is the comparison of the two systems. What we found in our study was that for 500 funnel units, the red is the injection molding, the blue is the 3D printing version. The injection molding was roughly 7 times worse for the environment than the 3D printing process. And we took in a lot of considerations with this. So that was extremely surprising right off the bat. And to break it down a little bit more in terms of these studies, we do more than just carbon footprint. We look at cumulative energy, toxicity to the environment, everything. But in terms of cumulative energy, you can see the impacts between the two technologies. The injection molding was drastically worse on the environment in terms of non-removable or renewable fossil fuels. And so in category after category, for 500 of these funnels, we saw that 3D printing was way better for the environment. Even breaking it down further, going into you know, impacts potentially on freshwater, mineral uses, land usage, toxicity, acidification. So there's a lot of things that when you do these studies that you look at downstream from start to finish. And again, the red and the blue, the red being the injection molding, it's just always worse on the environment. So we were very surprised by this. In most cases, the 3D printing was less than 30% in comparison to the injection molding process. So this was very telling when we saw the data, and we realized, you know, this is really something here. However, and there is always a however in science, there was a transition when we started looking at, well, how much is there a change when we increase the count? When we go from 500 to maybe 5,000 to 10,000 units, what happens? And that also was very telling. So what you see on the screen here are the comparisons of the carbon footprint when we went from 5,000 units to 10,000 units. The 5,000 unit point, we're still below injection molding, but we are closing in on its overall carbon footprint. When we cross the 10,000 mark, we're actually exceeding the carbon footprint. So there was a zone of where additive no longer was beneficial in comparison to the two. However, I want to caution you on this because there's another factor that we'll talk about in a second that may shift this data as well. So we saw this information, we said, okay, well, this is a pretty big deal. It's very telling in terms of the results. What about the cost? What about the lead times? So we contacted a couple of companies. Actually, one of them is in Ohio. It's ICO Mode, and got some quotes from them in terms, and lead time quotes, in terms of their injection molding process and how much would it cost to make some molds for us, and what would their product cost be. Some companies gave us ridiculous numbers, and some companies, you know, didn't even want to look at it from a molding standpoint. So we used their data from Protolabs and ICO Mode, and you can kind of see it on the screen here. Down toward the bottom, just to give you some basics, your ICO mold was about $5,500. 3D printing to produce what we're doing with shipping and everything included, about $1,000. And so you can see the lead times as well. About 40 days to 3D print 1,000 units, about 18, 20 days to injection mold it. But look at your savings. You can save quite a bit of money by using a 3D printer. If you go to 5,000 units, you can save even more amount of money. And you go to 10,000, a lot of money. But the problem is you're looking at a long lead time, over a year to use one 3D printer to make all that. So in looking at that study, we said, okay, well, since we're saving so much money with the 3D printer, what if we switched over to using 5? So $5,000 investment, get you 5 printers. Now we're talking 8 days for 1,000 parts, 40 days for 5,000, still up to around 80 for 10,000. And then we even asked the question, well, what about going to 10 units? And then you can see the data across the bottom. So there was a lot of decision making here, and one of the things that I want to really focus on this particular slide is the fact of when you do an injection molding mold, when you buy that steel, you're stuck. You know, that is a sunk cost. You're not going to be able to sell that steel off. You scrap it and make a little bit of money back, but you're not going to have any value. You've lost the money when you've actually bought that mold. But with a 3D printer, that's not the same case. With a 3D printer, you're potentially going to be able to switch the printer to a different product, possibly resell it, and you're going to be able to recapture that sunk cost or recapture that investment, unlike the mold. Now, another thing that I want to point out too is, again, in this environmental study, the major impact and the reason that injection molding was more, I guess you could say, hazardous for the environment was because of the steel. And with this in mind, we want to talk about design changes. So actually this occurred on the project. We actually did our first run production, and while playing around with it and getting some feedback and that kind of thing, while she was actually using them as their marketing material at the gym, she said, some folks have said, you know what would be great? You know, it's got this little tab on the side and that's cool, but you know what would be awesome is why don't you add a hole for a key ring? And you know what, with additive, it was like, awesome idea, boom, that afternoon it's done, production's changed over, no problems. Adding that hole simple for us. But if we had to injection mold this part, that may have been a big deal, depending on how the original setup of the mold was. Adding that hole could have been a significant change and possibly requiring a brand new mold. Now you'll remember that I said watch out for this data in terms of the steel. The moment that you introduce a new mold into the process or you have to redo the mold, that immediately sets back your environmental impact from the actual environmental results. So suddenly, the moment that mold is touched or a change is made, additive once again becomes the leader in terms of better for the environment. So that was a big change. Another thing that changed along the way were these spirals that you see right here. This was actually used to help torque the funnel into the bottle a little bit better to help it hold, and a little bit more complex shape that definitely would have required some retooling on the mold side. And again, that would have bumped and swapped the environmental impacts of the two systems. So this data was extremely telling to us, and we started seeing there's a whole lot more decisions to be made here. The steel mold was the worst for the environment, dealing with the steel, and additive involved a lot of potential cost benefits. Additive's weakness, though, was the speed. However, that could be offset since you're saving so much money and you get a payback on the additive equipment by just increasing your number of units, which is like what Prusa does. What's also very much impacted by the study was the concept of iteration and design change. Shape matters, changes matter. So with this, and kind of wrap things up for us all, in terms of LCAM and our conclusions, you all have a great opportunity. You know, with this equipment that you're integrating within your classrooms, additive integration is the step we need to get more companies moving in the right direction, making them aware of these next generation products that they're going to be asked to produce, missed opportunities that they don't even realize because they're not actually already using it. Additive also gives us significant competitive advantage to companies that begin with additive production because they can constantly iterate and constantly improve their product. We're trying to find a way to quantify that right now. You know, how do we put a value to that competitive advantage? And how do we get a competitive or quantifiable value for consumer gratification, like instant gratification in some sense? And of course, we've seen the environmental benefits. There are benefits to be had there. Generally, though, you start producing a lot of parts, then conventional may become the better option. However, the moment conventional mold actually gets broken down or needs repaired or needs replaced, and that does happen, it immediately flips backwards. So there's a lot of decisions that need to be made that we've never had to make before in terms of manufacturing. So anyway, I want to thank you all for your time this morning. If you'd like to check out some of the work that we do, you can check us out on Facebook there. My email is also there. If you ever want to find us really easily, you can Google search us pretty quickly just by typing in SCC 3D printing. Will be the first hit after the ads. You can go to our webpage, and we've got this blue button down toward the bottom where it'll take you to our cloud drive, and we share all of our case studies, information like this, and a lot of videos that we've made in terms of additive economics, some of the new techniques we've come up with, and it's all available there on from NSF. So at this point in time, I'll kind of open the floor for any questions, and just want to say thanks as well for paying attention this morning.
Great. Thank you, Eric. One of the topics that came up yesterday was, is there recyclable 3D materials available yet?
There are. There's a tremendous amount of study. Of course, you know, some folks are actually going into buying equipment that recycles their scrap, and that's one way a person can do it. Also, the study that we just saw, it was maybe like 2 weeks ago, that they've managed to come up with a process that can convert, and of course this is only in lab so far, that can convert recyclable waste into a variety of different plastic properties with just the waste itself. I haven't had a chance to be in finals and doing a lot of training this week, so I haven't got into it a whole lot. But there was a pretty significant breakthrough a couple weeks ago that's definitely going to have impact on additive.
Well, that's good news. That is good news. Are there any other questions from our group? Oh my gosh, they're quiet. I've never heard teachers so quiet.
Take it all in. That's what we're going for.
What would be some recommendations for how you like to do it at the that would, you know, pay down the road?
So what would be, the question was, how do you see this type of technology getting incorporated into the middle school, early high school environment to help benefit collegiate level instruction?
That is a great question. And to put it simply, when you all get started, you know, you're having this great workshop, you're getting the new printers, and you're going to start off doing simple stuff. You're going to be downloading things from Thingiverse. You're going to be making keychains and trinkets, and that's awesome. That's where you start. But what we want you to think about in this process is to step beyond that. Your opportunity, your gateway here is to start solving some real problems with the equipment once you get comfortable with it. It may be a simple little bracket. It may be something that the library has a part that keeps breaking, and then you step in and say, hey, we can make you a replacement part, and we can redesign it just a little bit so it no longer breaks. And you may know someone, or someone knows someone who has a little small company that makes this or that, and you might want to step in and say, you know, we got a 3D printer, let's see if we can fix this problem for you. Your end game here is to start using the printer for things that really matter in production. Doesn't have to be huge, doesn't have to be grand. It just needs to be something that really matters. You want to step yourself beyond the keychains and trinkets, and you want to do things that actually solve a real problem. The moment you start doing that, it also gets the students in the right mentality. It starts getting folks paying attention a little bit more to what you're doing, and it starts getting them a little bit more interested in additive. The results, even at the middle school and high school level, are going to be good PR, good recognition, and these companies are going to start to pay attention of what you're doing even at that level, and they're going to start to say, you know what, you know, maybe one of these high school students that you've got that's using this 3D printer, why don't they come do a summer internship with us? Maybe they come and show us what they're doing. The more real stuff that you make and the more problems you solve, the more impact you're going to have, and it's really going to make a huge difference.
So as Project Lead the Way Schools, you've got advisory committees, I believe, correct? That's a great area that you can leverage to get projects or have individuals from industry come in and share a concept idea of, we have a problem to solve, and have your students work towards that resolution.
Absolutely. And to be fair, again, we actually have this, I sit on one of the advisory boards for our local Project Lead the Way, and I sit on a board of individuals and manufacturers, and some of these guys who are in robotics don't even have a 3D printer in their shop. And it just astounds me as a company that is making like from scratch new parts, doesn't realize what's going on. And so it'll be your task to really just make them aware of what is possible, because we still have companies that when we say 3D printing, they think we're talking about taking a block of material and CNCing out a part. And these are major, major companies. So just quick, simple solutions, awareness on those advisory boards, get them showing what's going on, play some YouTube videos. I mean, YouTube's got a ton of 3D printing videos that help explain how additive is different than conventional. Just have that stuff playing and you can get some great opportunities. And really, it only takes like one simple project. That one that I showed you early on, we were making very, very simple little brackets for encoders that they were paying like 20 bucks for plus shipping. And they made, you know, several $100s in savings right off the bat. So it can be the simplest thing, but you've got to kind of give them a little push.
Other questions? I think they really want to get back to their projects so they can start printing here, Erid. Thank you so much for joining us this morning on a Saturday. And,
well, it's a pretty one, and the opportunity to do it here from the farm lab was pretty awesome. So I appreciate the opportunity, and I wish you all well. Have a great time with this, and you know, get out there and just make some noise for additive. It's the solution we need for next generation products. And the sooner we accelerate, the more people are thinking this way, the better the benefits for us all.
Absolutely. Thanks again. And last minute question.
Oh, go ahead.
So where does the United States fall into the rest of the world rankings with additive manufacturing and generative design?
Okay, so that's an excellent question. We are a little bit behind, to be honest. Europe is ahead of us. Even Australia actually has some leads in certain areas over us. Surprisingly, China is doing a lot. If I were going to say who's, for example, in the 3D printing of building construction, China has us beat. They've been doing it a lot longer than we have. But the U.S., a lot of U.S. companies are waking up quickly and are transitioning. One of the areas that we're seeing a lot of lag, and probably rightly so, is in the medical industry because of FDA approval for many processes. Some companies internationally are getting a little bit ahead of themselves. They are being successful, but our safety procedures are also, you know, cautiously approaching it. One of the things that we have seen that needs to happen is that insurance needs to sort of wake up for additive applications within the medical fields. Case in point, we've been able to 3D print CT scans and MRIs for, you know, since 2014. And yet insurance companies are not even paying for that yet. And it only takes us like 20 minutes to do it, maybe an hour to produce the part. But we approach these medical practitioners, and since insurance is not covering it, they're not really interested. Now, the prosthesis is a different story, and there's a lot of movements there. We were very fortunate. Actually, this semester, I had a guy from South America, who was in Guatemala specifically, who took my class just so he can start producing prosthesis in his home regions using low-cost additive manufacturing equipment. So America is probably a little bit behind, but fortunately with GE, HP, and all of these large companies getting into this and all the money, I mean, we're talking billions of dollars in transition money right now. We're probably going to see a big change. So we're not too far behind right now, and I think we're catching up.
Excellent. Thank you, Eric. Have a great day.
Thank you all, and enjoy yourselves.